So I've clicked on this going live now, and we can start it now. Okay, just watch it here now, and this is end stream. See, let us recall first all those things which we have studied in the previous class. Okay, let us recall all those things which we have studied in the previous class. So first we have studied this reflection of light. Refraction of light. Okay, this we have seen. Next, we have practiced some numericals. Okay, I mean, today what we are going to do? Today we'll see again a little bit of the theory from where we left in the previous classes. Reflection of light. ये हो गया था ना? Sneha, was it clear? Yes or no? Can you text or chat? Like you can tell here. Reflection of light was cleared. No, in the previous class we have completed this.
Yes,
Yes.
sir.
Okay, good. So now I'll practice the numericals also. So in the today's class, what we will do? So that was a recall portion. Okay, that portion was what? That portion was the recall portion. But in today's class, what we are going to do? In today's class, we'll solve the numericals also. Plus, we'll see the new theory topic, that is apparent depth and normal shift. Okay. After this, we'll be seeing here lateral shift topic. Okay. After that, critical angle. Starting from this. Okay. See, but at least our goal is this today. At least, कैसे भी करके today you have to complete at least this topic, apparent depth and normal shift. Okay, by solving the connected numericals with this, constrained numericals with this connected. Okay. So let us go through the recall first. So this is a recall thing here. Just hold, let me see the charge, how much in the laptop. Fully charged. Okay, so this is a recall. ठीक. Laws of reflection is this. So what it says like this: incident ray normal to any refracting surface at a point of incidence and the refracted ray all lie in the same plane, called the plane of incidence or the plane of refraction. Okay, so suppose this is a boundary. This is a boundary which is separating two mediums. Okay, this is medium with refractive index n2. Okay, this is the medium with refractive index n1. समझ में आ गया? Medium 1, medium 2. So here the first law says like this: this incident ray, this refracted ray, and this n dash, which is basically the normal, all they are lying in the same plane. Okay, next it says like this: sine of the angle r is what? It's a constant. Okay, for any pair of media and for light of given wavelength. Got it? This is the second law of refraction. I mean, this is the second law of refraction. Basically, this law is known as Snell's law. Okay, and it is also what? Combined with this kind of a structured formula, in which the things which are connected are like this. That is, see, n is the symbol used for refractive index. Okay, we know this thing. It's a property of the medium, na? Speed is for, see, when we say one subscript, it means connected with the medium which is having the refractive index with subscript 1. Okay, it's the speed of the light in this medium. V2 is the speed of light in the medium which is having refractive index N2. Also the corresponding wavelengths, because light is what? Light is an electromagnetic wave. Okay, got it, students? Sneha and all. Okay, so this is one student only. Okay, so this will connect like this. And like for, we know this thing in the previous class we have seen, for applying in problems like, applications, okay, we'll use this method properly. That is n1 sin I equals to n2 sin R. Okay, where I is known as what? Angle of incidence, and R is what? Angle of refraction. Okay, n1 sin I, n2 sin R. n1 sin I, n2 sin R. Always remember this formula, it's very important because I have highlighted here also. Okay, got it? See, if somewhere they give you this symbol like this, 1 and 2, it means refractive index of second medium with respect to first medium. Refractive index of the second medium with respect to the first medium. समझ में आ गया students? Got this thing? ठीक है? Yes? Yes? Okay, very good. Excellent. Excellent, students. Okay, now this question as a recall question for you, solve it yourself. Now this I'm providing on the slide, a recall question, solve it yourself. Recall, recall question. Okay. Okay, students. Recall question. So try to solve it now. Try to solve this. Try to solve it and text me the answer if you are able to solve it. Otherwise, I'll give you the solution now. See, because it's a recall question, no? How can I solve the recall question? It's not good. I mean, because it, by solving this question in the class, you'll get an idea that where you stand basically. Solve it. Question. Okay, let me give you the hint. Isme karna kya? What do we need to do? Let me give you the hint here. So hint is this. Hint is this. Okay, that you have to use this structured formula. This slide. It's like this. So let me give you the proper, a very proper hint. It's like this: sine of the angle of incidence. And you know everything. What is incidence? What is the sine? Sine is from a trigonometry of function, trigonometric function. Okay, na? It's a trigonometric function. Got it? Very good. Sine are opposite. है ना? N2 upon N1. An application formula we know, just cross multiply. This was the applicatory formula. This everyone knows. And this is connected with speed of the light in medium, which is having the refractive index 1. So it's cross, it's like opposite, it's inversely proportional. Remember always, the respective speeds of the light and their wavelengths in a particular medium is inversely proportional to that medium. Okay, you can see it from here, no? Is it okay? Very good. See, it's like this. So let me cover this in a blue color. Down. It's like this. Okay, covered. You can see here, you can observe this thing from here that refractive indices is C subscript, again subscript, proportional to their lambda and proportional to their speeds, inversely proportional. Very good, excellent. So you got the answer 8.16 times to per 7 meter per second. So let us check it out, Sneha, ki is this answer right or wrong? Okay. So let me end the video here. It may create a stucks in the network. So let us observe this question. It says, angle of incidence is 45 degree, angle of refraction is 60 degree, speed of the light in the medium A, they're asking from us, And the speed of the light in the medium B is given by C by 3. Cool. Apply the formulas. So inversely proportional relation is like this. Speed of the light in what kind of thing? Medium A. Medium A equals to upon speed of light in medium V equals to, if I do it up here like this, okay, speed of light in medium A, speed of light in a medium B, and right here, velocity of light in medium B, velocity of light in medium A, lambda of light in medium B, lambda of light in medium A. Okay, but our requirement is what? If you see the question, it says here, medium A may they're asking from us to find in medium A. Hold on. Hold on, students. So in the medium A, they have given us they have not given us the velocity, but they have given the angle 45 degree. Okay. Okay. One more thing we have to connect here: sine of I, sine of R. I is for what? I angle is in what? See, with respect to medium 1. So it's medium 1. It's like this. Okay. We'll connect it opposite. So now we'll connect the velocities. So if you're putting here sine I is 45 degree, you keep the velocities for its velocity is VA. Okay. VB we know it's given here C by 3. And sine R is 60 degree. We know the connected values with this. What is this? 1 by root 2. इसमें क्या है? Under root 3 by 2. ठीक है? इसमें if you'll solve this thing, you'll get VA is equals to C by 3 root 3 by 2, ठीक है, into root 2. इसमें से this is equals to what? Root 3 by 2. VA is equals to C by 3. C by 3 root 2. Okay, you can solve this more better in this manner. That is, this will give you the value equals to C by root 6. Is this the answer? I think there is some mistake or what? No, it's fine. Sine I will be for that A medium. Okay. See, A medium a 45 degree angle hai. So velocity will be with this 60 degree with the velocity B. Okay. If you're going to put here 45 degree, you have to put here 60 degree. Then you have to use V1. Okay. I mean, you will use VA here because it's opposite. Okay. These are opposite. You'll use VA here and you will use VB here. VB here is C by 3. Okay. So you'll get C by 3. This is sine 60 root 3 by 2. This is 1 by root 2. This will give you root 2 here. So from this, you get C by root 6 is the answer. Got it? This is the meter per second speed of the medium A. Is it right? Okay. Now let us move towards the apparent depth in the normal shift, a new topic. Sneha, is that okay? Is that numerical fine? Yes or
Yes.
no? Okay, good. So your answer was 8 point something, na? What was the issue there? See, always remember that sine of, if the medium is I mean, if you're considering like this, N1 and N2, and this is normal. If this is the angle of incidence, okay, this will be the angle of reflection. I don't know where it's, okay, let us take this up to second medium R angle. So you write like this, okay? That's why we make the application formula, no? N1 sine I, N2 sine I. So if this is I of A medium, this will be, velocities are reversed. So this will be VA. Hold on, this will be VA. If this is 1, this will be VA and this will be VB. Okay. So sine 45, 1 by root 2, sine 60, root 3 by 2. VA is here. Okay. And this will be VB. VB we know it's given here what? Equals to, again I'm solving for you. VB is what? C by 3. VA we want. करोगे solve आ जाएगा answer. Okay, this is equals to 2 by root 3. 1 by root. Okay, it's coming somewhat different. Hold on. Okay, so it's coming C root 2 by 3. Okay, check it out, the two answers. Okay, maybe some calculation mistake. Check it out. Okay, let us proceed towards this, the main part here. Okay, this is the main part here. Let us proceed towards this. So apparent depth and normal shift. Just focus on the theory. See, that was a numerical, maybe mathematical issue will be there. You have to check it out. Okay. So now apparent depth and the normal shift. What is this? What is this apparent depth and normal shift? Now, I'll give you the PDF solution. Okay, don't worry. Focus here. See what happens. This topic, that is the apparent depth and the normal shift, it follows the theory or the phenomenon of what? Basically, physics behind this is of completely of reflection. Okay. What is actually happening in this? See, these are two examples in front of you. Suppose you're standing here, okay, on the boundary of like some rock, and there's a pond kind of thing here. Somewhere you are. See, fish actual location is this, shown by this kind of blacky color. But what you will observe is this, that the fish is not here, but fish is actually here. To your eyes, it will appear that the fish is actually up, not at the this depth. So this is, we know from this boundary, if I consider, this is what? This is what? This is the boundary separating two mediums, that is air and the next is water. This is the boundary separating two mediums, air and water. Fish is at real depth. Okay. But to your eyes, it will appear here. Why was the reason? Because we know this thing. When a ray of light passes from water, a denser medium, to a rarer medium, if you draw a normal, let us see the physics behind this. If a ray of light passes from a denser medium to a rarer medium, it bends away from the normal such that the angle of reflection is greater than I. If you extend this back, it will meet here. This will give you the image of the fish, which is a fake image, which is not a real. We know this thing. Or if you can consider this example, if you take a bucket of water from anywhere, a bucket, and put a coin in that bucket at the base of the on the base of that coin platform. Okay. So if you see from the top, the coin will appear to you with rise with some level. Got it? The coin will appear to you like it has been like it has rise with some level. Risen. Okay. So the reason is what? The reason is this same apparent thing. Normal shift we'll see. Similarly, if you see, suppose this is again second kind of picture, and suppose this is some factory worker, okay, and like in the factory things are there, water is there, everything. It's like washing process is going on. Suppose this kind of some material is there, which is actually it's heavy material, some very heavy metallic kind of material. It is basically on this base platform, okay, which is having the actual depth given by this actual depth. Say suppose it is say D, simple D. But if you are watching, if you're seeing it from the top layer to your eyes, it will appear that it is not that actual depth. You will say to someone, if I come here, like this, suppose this is me. If I'm asking from him, hey, tell me, what's the actual depth of the block? He will take a stick and he will measure like so. He will say like this, sir. The actual depth to his eyes will appear to be what like this, which is actually the apparent depth we have seen. What's the reason? Because as the light ray is passing from this is an angle of incidence, from a denser medium to a rarer medium, it will deviate away from the normal like this, and it will meet here. Okay. So we can conclude like this, that apparent depth, this is the apparent depth. Okay. This is what, less or greater? We know this, it's less than the real depth. Remember all this. Apparent depth is what? Less than the real depth. So we can conclude in this thing that when the object, I'm writing a statement, please note it down in your notes copy. It's important. When the object is in denser medium, when the object is in denser medium, Okay. And if you are observing that object, if the observer is in rarer medium, if the observer is in rarer medium, so we'll say if this is apparent depth d dash, well, let me mark it with say d dash. I'm giving this apparent depth the symbol as d dash. So I will say this d dash quantity will be so d will be greater than d dash in this case. We will also see in the numericals that what will happen if the observer is in the denser medium. No, sorry. If the object is in the rarer medium, say bird. Suppose you are in the water, swimming pool inside the water, and if you're observing some aeroplane or some bird going with some height flying, or it's somewhere it's like this flying above the boundary like this. Suppose there is bird here. Okay, let me draw it here. Let me draw it. Suppose this is bird and it's at a height h from the boundary flying. If you are inside the water, like fish, suppose you became fish, somehow magic happened and you become a fish. So what's going to happen? You'll see like this, that this bird, which is actually at a height, which is a real height, h, to your eyes, it will appear like this, that this bird is far away. Okay. To your eyes, it will appear like this, that this bird is far away. Okay, which h dash. So in this case, we'll say like this, apparent height here is greater than the real height. Got it? So when you're observing from water, the things changes. Why? Because the medium changes. Understood this thing? If you make the ray diagram for this, I will show you in the question how the ray diagram, when we draw it, what happens. Okay, before proceeding towards the mathematical formulation, which is connected with this question, physics, is the physical significance clear to you or not? Text me. Is the physical significance clear or not? I'm waiting. Okay, text me here. So at least I can start the mathematical formulation on the next slide. Is this clear? Good. Yes, good. Now I'll see this mathematical formulation. Just wait for a second. No, you can draw the diagram in your notes. You can draw the diagram in your notes. See this thing now. Okay. Now watch it carefully. Let me give you here a mathematical formulation properly. Okay. Mathematical formulation कैसे देंगे इसमें? What it will be? Let us see now. See this. Suppose the object is here. Okay. And this object is actually, we know it's at how much depth? It's the depth is d. This is the d depth of the object. Okay. See, I've already drawn the ray diagrams. So the ray is going like this. We know this. If you're standing here, this is suppose our eyes. So to our eyes, it will appear like this, that the image is here. Okay. Apparent depth will be how much? This d dash and d. So the relation is this. Remember always. I will write like this. N2, which is if we are in the rare, remember this, if we are in the rarer medium. I'm audible, no? N2 if we are in the rarer medium. N1 if we are in the denser medium. Okay, so I will write like this, N2 upon N1, okay, equals to apparent depth N1 is what? The real depth. I mean, in that medium it is, no? The real depth. You can write here apparent means d dash Real means D. So this will give you a formula like this, which you have to remember. Okay, remember this formula. We'll just now solve a question based on this. So is this mathematical formulation clear? No need of derivation. I mean, just remember the application. Just remember this formula and understand the application how to apply, because they will not give you a consecutive. Consecutive, they'll give, if they give the consecutive, layer by layer, we'll see what's going to happen. I mean, apply this formula. I'll tell you the next miracles. You'll get an idea. Yes? Okay. So write this formula and few important points which are connected to this. Let me highlight this formula. So I have highlighted this formula. Just wait. I've highlighted it. You can see in your screens. It's well highlighted. Remember it always. Okay, let us make a case. What happens? Okay, before this, let us see one more thing here. So above formula is only valid for paraxial rays, is what? Making very small angle. And distance should be taken from the surface. Remember it also. That boundary separating two medium. Always, whether you're observing a bird from the water or a plane from the water, or if you're observing a fish from the top, like you are a bird and you're observing the fish. Okay. N2 here is a refractive index of the medium where the ray is going, and N1 is that from the where the ray is coming. Remember it always. N2 is कौन सा है from where the ray is going, and N1 is what from where the ray is coming. So you can see N1 is what from where the ray is coming. This is coming. N2 is what where it's going to our eyes. To our eyes, it's going and coming from N1. Okay. Now let us change the case. Okay, before solving this question, let us make a different case now. What happens? Suppose this is a boundary separating two mediums. This is a boundary separating two mediums, and this is a water here. Water, 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 water. Okay, this is what? Water, a denser medium, which is having a refractive index 4/3. Okay, this mu is what? 1. This is suppose air. Got it? So suppose students, what do we need to do here? Any one of you? क्या करना चाहिए? What do we need to do? Okay, suppose let us draw a normal like this. Take, and suppose we are in the water. We are having a tube like this. I can't bring the diagram here. Somehow we are in the water. Suppose fish is there. Okay, remember which fish you are? Yellow fish, golden fish. Suppose fish is there. This is fish. Okay, here also some fish is there. So different kind of, like aquatic life. It's aquatic life. Let's make different structures of aquatic life. Okay, so whatever. Okay, suppose the creature. Okay, I mean, if there is a bird flying at a height h, always remember this is suppose a real height of the bird flying. Capital H is the real height of the bird. Let me charge it. Capital H is the real height of the bird flying. This is the bird. Okay. One bird. Okay. Okay, I'm removing these things, erasing these things. This is one bird. Okay. H height, real height of the bird flying. Okay. Okay, let us make the ray diagrams. Let us observe what happens if we are observing this bird from the water. Okay. So if the fish is coming like this, and the rays from the bird is coming like this is I. We know this thing, this is the medium which is having the refractive index 1. This is the medium which is having the refractive index 4/3. I repeat it. Above is the refractive index. Above is the medium which is having the refractive index 1. And the down is the refractive index. Down is the medium which is the water having the refractive index 4/3. So when the ray is coming from this top to inside the water, that is from the rarer medium to this denser medium. Okay, what's going to happen? We know this thing. When the ray enters from the denser to the rarer, it deviates away from the normal. If the ray enters from the rarer medium to the denser medium, it will bend towards the normal. So now it will decrease its angle. It means it is now bending towards the normal. So we can say here, angle of incidence in this is greater than R. Initially क्या था? Refraction angle ज़्यादा था. So if it bends like this, if I extend it back, I can see that to you, the bird will appear here. Okay. So you will say that the bird's location, which you will see from inside the water, it will be what? It will be like this. That suppose it is at this much height, h dash. And we know this thing. This is not a real height. This is greater. That's fine. Initially, the apparent thing was less than the main magnitude, the real magnitude. Here, the apparent magnitude is more. Fine. But it's not a real. We know this thing. So right here, it's like what? Apparent height of the bird. Simple. So now apply that mathematical. Now I will put here the mathematical formulation. I mean, if I'm writing here the mathematical formula, how I will write? Okay. So if suppose I say, now they have said what? Rays from where the rays are coming. I mean, from the where the rays are going. It's, you can see no note. What was the note? See note. N2 is the refractive index of the medium where the ray is going. In the इस case में क्या था? इस case में it was rarer medium. And N1 is the refractiveness from where the ray is coming. That is object. Object matlab N1. Object matlab N1. Okay. So I'll write here. If I write the formulas, object matlab N1. So यहाँ पे object is this thing now, not the fish, because we are observing the bird. Bird is the object. We are the observer. We are the fish now. So इसमें object ये है. ठीक है? So N1 means O, and the formula is this: N2 upon N1. Okay, this was same. Apparent height h dash, real height h. Okay, N2 कितना है? N2 will be what? N2 was from where? I mean, N1 was what? From, so you can see, no? N1 कितना था? What was the N1? Where the ray is coming. Okay, so if I write here, N1 means what? When the ray is coming. Coming मतलब यहाँ से object से आ रही है. Ray is coming from the object. See this? It's coming from the object. Okay, so I will write this medium, that is N1. I will write. Now we have to reverse the things. Okay, got it? इसमें things को reverse करना है. So you will put here what? 1. N1 is the from where the ray is coming. Okay, 1 going towards N2, that is water here. 4/3. And rest of the thing is same. So you convert 4 by, you will create like this. Whatever the height given, but this will give you the, if this original real height is given, this will give you the apparent height. But remember, heights or the depths, ऊपर जाएंगे तो heights or the depths are measured by considering this straight line, that is the reference line which is separating, or the boundary line which is separating two mediums, say water or denser medium, whatever, with reference to this. If they're asking from with respect to the bird particularly, when to the fish, if you're observing the fish, or when they're asking the bird, when they're asking the bird's height with respect to fish when we are in the water, so we have to use the complete distance. Okay, we can add then. Okay, got it? I will tell you in the question. Up to this much clear or not? This thing is clear. If you see that question, you know, denser this one. So इसमें क्या put करेंगे? Suppose this. Let me show you here. Suppose this N2 is no, we know it is what? 1 here. N1 is what? 4/3. इसमें put करेंगे क्या आएगा? This is opposite. See, it's 1/4/3. Same. क्या आंसर आएगा? It is 3/4 apparent and real. 3/4 apparent and real. But if you see that the next case 4/3. So this is the difference. Other things now is all I hope from you. Okay. So this is the thing here. Find out the flowing in the figure shown below. This is a practice numerical for you. Okay, let me put this off the video. Okay, one more student have joined. Manpreet Singh have joined. Welcome to the class. You're somewhat late. Is it? Okay, no issues. I think you have joined earlier. No, I didn't focus there. No issues. Good. So see, solve this question now. It's a practice question based on the theory, which is like now only provided to you. Practice this question. Okay. So see, this is what? This is a surface which is separating two mediums. This is water, denser medium. This is what? Rarer medium, bird. Okay. So first they're asking the apparent distance of the fish from the surface as observed by the bird. First they're asking apparent distance of the fish from the surface as observed by the bird. Fish ka apparent distance kitna hoga as observed by the bird. Okay. Simple. It will be the fish will appear to us that it has like, let me draw the diagram, that it has like risen with some, I'll say with some, say, height. So this will be the d dash, and d we know from the surface is what? 36. Apply the formula. Same for the b also. Do you want me to solve, or you can solve it easily? I think. Yeah, got it. Okay, I'm solving this first question for you fast. So see, apply the formula. This is a picture given in front of you. So we know d dash upon d is equals to n1 is from where the ray is coming, n2 is from where the ray is going. So n2 is going towards the bird, n1 is coming from the fish. Remember, so d dash we want, d is how much? Taking the distances from the surface. Sorry, taking the distances from the surface, this is how much? 36. Take a 36. N2 is what? 1. N1 is 4 by 3. So they were asking you d dash value. Can't you find it out? D dash is equals to 36 3 by 4. 4 1 is 4. 4 9 is 36. 9 3 is 27. So from this we get this d dash value is equals to 27 centimeter. Got this thing? D dash value is equals to what? It is equals to 27 centimeters. 27 centimeters. Okay? Which is a less value. So one more thing, less than D. Clear? Now the next part. Next part it says what happens, we switch the condition, switch the places. Initially I was a bird observing the fish. Now I am inside the water. I am the fish observing the bird flying at height h. This case may the conditions will change. We will apply this case here. So this formula directly I'll apply. Okay. I will say like this. If I need to observe the fish, 4 by 3 from where the ray is coming, that is the, sorry, 4 by 3. Okay. So it was basically, if you see this formula is n2 upon n1. But in this case, apparent, okay. So this was 4 by 3 is what? I'm observing the fish. So ray is coming from the fish side now. Okay. And going towards what? This n1. So apply this formula direct. Or it's easy. You know, if you see this case, you'll get the idea. Just opposite the things. Take an initial ke opposite kar dena. So this will be 1. Apparent height is h dash. The real height is 36 centimeters. Solve this thing. इसमें कुछ issue है. Hold on. No, it's fine. 4 by 3, 36 h dash. Solve करेंगे कितना आएगा? H dash comes out to be 48 centimeters, students. So you can see the real depth, real height is of the bird is 36 centimeter, and apparent is coming as 48 centimeter, which is greater. So इसमें some change है ना? So I told you if you switch the positions, apparent height here is greater than that. But in initial case, here you can see this apparent is less than the real when we are observing in the water. But if I come there, it switches the position. It switches the positions, heights. Apparent is greater now. Is this in clear or not? Okay, you want to note it down, or let us proceed towards the next topic somewhat. I'll give the solution. I mean, I'll give you that topic little bit theory, but we'll solve the question in the next class. Okay? Is it fine?
Yes, sir.
Cool. So now let us proceed. Thanks for the reply here. So see, Same question, okay, same question, and it's like this. Suppose if you're observing, if you're like if you go somewhere in the aquarium, okay, in the schools aquarium are available, in the homes also some people keep the aquarium big, or in the museum, of course, there is a complete crowd of the fishes. So if you're observing a aquarium, and the fish in the aquarium, one fish, suppose the fish is heading towards you. See one thing, once you are observing a fish in the aquarium, this is a denser medium. Of course, the original position hogi fish ki, that you will not able to see because it's risen. We have seen now, Suppose this is the fish, starfish. Suppose this is starfish. It's laughing. Okay. And this is the eye. Eye. See, when the ray of light is going from this medium, that is say N1, say 4/3 denser medium, towards N2, which is a rarer air medium. Okay. We know the ray bends away from the normal. This is the concept. If the ray goes from denser to rarer, bends away from the normal. If ray goes from rarer to denser, it bends towards the normal. So here angle of refraction will be greater than angle I. समझ में आ गया? And when it's extended back, I'll find the starfish image to be here. So to my eye, I will, if someone asks from me, hey, where is, how much with, with respect to this boundary, say P, see P dash, with respect to this boundary P dash, where's the starfish is, at how much distance inside in magnitude the starfish is, I will say it's Y, but someone intelligent will say me, see, if you see from here, you will find original location, actual magnitude, AM magnitude of the starfish is in magnitude, it's X distance inside. If you see from the top, it's in depth. Got it? And the what do we say? Fake apparent. This is the actual or real. Let me write it RM. And apparent means apparent magnitude is Y, which is less. Consider the same as reverse this photo like this, and you will find the cases which are I've given you the first for two photos. These photos. Got it? Ryzen no. इसको ऐसे tilt कर दो. You'll get the thing. Okay. Okay. Now the main case is this. Suppose this fish is heading towards, the original fish is actually heading towards you. If you see in the aquarium, the starfish is coming towards you in a very smiley face, maybe. It depends, maybe angry. So it's coming towards you. Okay, of course, that, see, the fish you are seeing is not the original, it's not at original location. It's you'll be seeing the fake position, but the image will also be moving with some speed. Okay, so here if there's someone is asking from you, it just tell me that what is the velocity of image if you are given the velocity of the object, which is your fish. And also suppose the surface is also moving with Vs. So what do you comment on these vectors? So we want a relationship between these three vectors. So first of all, we'll derive an expression which will give us velocity of, I will derive an expression which will give me the velocity of the starfish image. So we will solve this by sitting, or with reference to this boundary separating two mediums. I'll solve this question with respect to the boundary separating two mediums. Okay, I'm standing here. So I will say, I know this formula. है ना? This is apparent, this is real. इसको ऐसे modification करना है, just differentiate both the sides with respect to time. Okay, you'll get like this, dy by dt. This is basically n2 by n1 dx by dt. Okay, this will give vis and this. Let me write this thing here. So this is the expression, that is, you'll get an expression like this, a very nice expression. Velocity of image with respect to surface is equals to n2 upon n1 velocity of object with respect to surface. Okay, velocity of image with respect to surface is equals to n2 upon n1 multiplied by velocity of object with respect to surface. Okay, we'll write like this, velocity of image with respect to ground minus velocity of that surface with respect to, this is a relative velocity concept. Now we have studied this thing, VAB, okay, is equals to VA minus VB. These are relative, these are as per our natural frame, ground. So this is, see, no need to write the ground. You can directly substitute like this. Okay, I mean it looks better. We know this thing already, है ना? This is n2 upon n1. N1 कौन सा from where the ray is coming, object. N2 is air there. Okay, equals to velocity of object minus velocity of surface. So this formula, students, you have to remember to solve the questions which are based on this velocity of object in a diffraction case. Got it? Is that okay? Yes. So now we'll see a question. Okay, I'm giving this question as a homework. Try it out. First question I'm solving fast. Okay. First question I'm solving fast, then I will end the class. This question is a homework for you, the second part. First question I am solving. So see, the bird is moving with 24 centimeter per second down like this. And this boundary, I mean, with this water kind of, just suppose the tank of the aquarium is moving like this with 1 centimeter per second. And the fish inside is also moving with 12 centimeter per second. So now they're asking from you apparent speed. Of course, the fish will be the image which you will see as per the bird's eye. You are the bird now. You will see that this is the image of the fish. This will be also moving with some speed vi, and the object is moving with 12 centimeter per second. Everything is moving. So they're asking from you apparent speed of the fish as observed by the bird. वो कितना होगा? Simple, apply the formula. Formula we know. The formula is this: velocity of image minus velocity of surface n2 upon c. No, it's n2 and two it's you can see this now ground wala, okay, water wala, I mean. So solar machine. Okay, maybe some hand. Is that screen visible fast? Maybe it's visible. Okay. Okay, that's fine. So see right here, velocity of object आएगा 12 centimeter surface one. Solve it. Ultimately, I'm writing a direct answer. Ultimately, you'll get like this, something like 33 or 37 by 4. Okay, we'll solve this thing. This will give you it's opposite, so this will give you. Okay, solve this thing yourself. Okay. I'll give you the solution in the PDF. Now we don't have. I have to end class time now. Fish. Okay, students. So that was all about the today's class. Okay. If I show you that slide fast, go see this. So fish ka speed was 12 and the image speed is 9, which is less. Got it? So this was the conclusion. That was all about today's class, and we'll meet in the next class with a fresh topic, that is shift. When the ray is incident and emergent, they will become parallel, but what's that magnitude? And also we'll see some other shifts. Okay, fine. So I'm ending the class. Bye bye everyone, all the YouTube students and these class students, Zoom students. Bye.